Hello students, let us continue the session on arithmetic progression. We had discussed 6 questions of exercise 5.2 of NCERT exemplar. Let's continue with question number 7. The question 7 is, in which of the following situations do the list of numbers involved form an AP? Give reason for your answers. First one, the fee charged from a student every month by a school for the whole session when the monthly fee is rupees 400. Here, the fee charged for a student every month by a school is rupees 400. So the fee charged from a student for the whole session will be like rupees 400 for 1 month, for next month also rupees 400, for next month also rupees 400, and it is continued till the last session. Here, when we observe A2 minus A1, the difference will be 0. A3 minus A2, the difference is 0. Since there is common difference, the series forms an arithmetic progression. The numbers involved in this series, it forms an arithmetic progression. Let's look at the second question. The fee charged every month by a school from class 1 to class 12th when the monthly fee for class 1 is rupees 250 and it is increased by rupees 50 for the next higher class. So it is like, let me write fee for first class. It will be rupees 250. Fee for second class will be rupees 250 plus 50 rupees is added, so it is rupees 300. For the next class, it is rupees 300 plus 50 rupees is added, rupees 350, and it continues. So it is like 250 for the first class, next class 300, next class 350, and it continues till the 12 terms. In this series, A2 minus A1 is rupees 50. A3 minus A2 is also rupees 50. Further, when you consider a term and the next term, the difference is rupees 50. Therefore, this series forms an arithmetic progression. Let us look into question 3. The amount of money in the account of Varun at the end of every year when rupees 1000 is deposited at simple interest. Remember, it's simple interest for 10% per annum. In this, the principal amount is rupees 1000. Rate of interest is 10% per annum. So number of years we have to consider as 1. So simple interest for the first year will be 1000 multiplied to 10 multiplied to 1 divided by 100, PTR upon 100. We get it as rupees 100. So what does it mean? So rupees 100 is credited at the end of each year in the account of Varun. Remember, money in the beginning of first year is rupees 1000 because he has deposited 1000 rupees in the beginning. At the end of first year, it has to be credited with the interest. So money at the end of first year, when interest is credited, will be for 1000 rupees we have to add 100, so we get 1110. So money credited after second year, at the end of second year, will be for 1100. Again rupees 100 is being added, it will become rupees 1300. At the end of third year, it will be rupees 1200 plus again 100 rupees is added, it becomes rupees 1300. For the next year, it becomes 1400. So the money at the end of each year, starting with the initial first year, will be like 1000, 1100, 1200, 1300, and it continues. Here the difference is 1100 minus 1000, it is same as 1300 minus 1200. So any two consecutive, if you take, the difference will be maintained. Therefore this series, this list of numbers forms an arithmetic progression. Next, question number 4. The number of bacteria in a certain food item after each second when they double in every second. For this question, I'll consider, let the number of bacteria present initially be X. So the number of bacteria after 1 second will be double, so it becomes 2x. After 2 seconds, it will be again double, 2 times of 2x, which is 4x. In the third second, after 3 seconds, again it is doubled, it becomes 8x. For the fourth second, it is once again doubled, it becomes 16x. Therefore it forms like x, 2x, 4x, 8x, 16x, and so on. Here what will be a2 minus a1? It will be 2x minus x, nothing but x. If you consider a3 minus a2, it will be 4x minus 2x, which will become 2x. Here no common difference. Therefore the list of numbers does not form an arithmetic progression. Question number 8. Justify whether it is true to say that the following are the nth term of an arithmetic progression. First one is 2n minus 3. If I consider an as 2n minus 3, the first term will be a1, it will be 2 times of 1 minus 3. which will become -1. Second term will be 2 times of 2 minus 3, it will become +1. Third term will be 2 times of 3 minus 3, which will become 3. Fourth term will be 2 times of 4 minus 3, 8 minus 3 is 5. Here a2 minus a1 will be 1 minus of -1, nothing but 2. a3 minus a2 will be 3 minus 1, which will become 2. a4 minus a3 will be 5 minus 3, again 2. Here there is common difference. Common difference exists, and the common difference is 2. Therefore, an equal to 2n minus 3, it forms nth term of arithmetic progression. In this way, we have to look at the next two. Let me consider the second sub. For that, I will write the question again. It is 3n square plus 5. I'll consider this as the nth term. What will be the first term then? I have to replace n with 1. We will be getting 3 plus 5, nothing but 8. a2 will be 3 times of 2 square plus 5. 2 square is 4, 4 3s are 12 plus 5, nothing but 17. The third term is 3 times of 3 square plus 5. 3 square is 9, 9 3s are 27, added to 5, we get it as 32. a4 will be 3 times of 4 square plus 5, we get 16 3s are 48 plus 5, nothing but 53. Here let's look at a2 minus a1. a2 minus a1 will be 17 minus 8, which will be 9. a3 minus a2 will be 32 minus 17. If you find the difference, it is 15. a4 minus a3 will be the fourth term, 53 minus the third term, 32. The difference is 21. Here there is no common difference. Whenever there is no common difference, we can say that the sequence formed 8, 17, 32, 53 is not an arithmetic progression. Therefore, 3n square plus 5 is not nth term of an arithmetic progression. Let us solve the third sub. In the third sub question, we have 1 plus n square. I'll consider this as nth term. So let me find the first term. I'll replace n with 1. I'll be getting 3. The second term will be 1 plus 2 plus 2 square, which is nothing but 1 plus 2 plus 4. We get it as 7. a3 is 1 plus 3 square. We get it as 1 plus 3 plus 9, which will be 13. Fourth term will be 1 plus 4 square. We get it as 1 plus 4 plus 16, nothing but 21. Here let me find a2 minus a1. a2 minus a1 is 7 minus 3, 4. a3 minus a2 will be 13 minus 7. We get it as 6. a4 minus a2 will be 21 minus 13. We get it as 8. Here you observe there is no common difference. Whenever there is no common difference, then I can say that the series 3, 7, 13, 21, 31, so on formed is not in arithmetic progression. In other words, I can say that 1 plus n square is not nth term of arithmetic progression. This completes exercise 5.2. Let's see exercise 5.3. The first question of 5.3 exercise is match the following. In that they have given some data in column A, we have to match with column B, and the column B is the suitable common differences. If you look at first column, they have given 2, -2, -6, -10. So let me work out here. The first term is 2, the second term is -2, the third term is -6. So if I find a2 minus a1, a2 minus a1 is -2 minus 2, which is -4. a3 minus a2 will be -6 minus of -2. We get -6 plus 2, nothing but -4. So it means that this first one, a1, matches with b4. So a1 matches with b4. Let's look at the second one. Nth term is given as 0. Nth term is given as 0. The first term is -18 and the number of terms is 10. If I use the formula an equal to a plus n minus 1 into d, a is -18 plus n minus 1 is 9 into d. So on transposing, it becomes +18 equal to 9d. So d will be equal to +2. +2 means it is option B5. So A2 matches with B5. Now I need to work out for the third and the fourth one. I'll erase a little part of this. In the third, we are given with the 10th term equal to 6 and the first term is 0. 10th term is a10, which is 6. So a plus 9d will be equal to 6. If you replace a with 0, 0 plus 9d will be 6. D will be equal to 6 by 9. So d value will be 2 by 3. 2 by 3 is present in the first option. So A3 matches with B1. Now the fourth one. Here we are given the 13th term. Second term and the fourth term. Second term is 13. It means A plus D will be 13. Fourth term is 3, which means a plus 3d will be 3. These are the two equations. If I do equation 2 minus equation 1, I'll be getting 2d equal to -10. So d value will be -5. So A4 matches with B2. So once again you can look at all the blanks or all the matches. A1 matches with B4, A2 matches with B5, A3 matches with B1, A4 matches with B2. Let us look at the second main question. The second main question is to verify that each of the following is an arithmetic progression and write its next three terms. We need to first identify whether it forms an arithmetic progression or not. For that, I will carry out a2 minus a1, which is 1 by 4 minus 0, nothing but 1 by 4. a3 minus a2, which is 1 by 2 minus 1 by 4. The LCM is 4, so 2 minus 1 will be there in the numerator and the denominator is 4. We get 1 by 4. a4 minus a3 is 3 upon 4 minus 1 upon 2. Once again the LCM is 4. So in the numerator we are left with 3 minus 2, nothing but 1 upon 4. Here there is common difference and the common difference is 1 upon 4. We need to write the next three terms. For writing next three terms, I'll consider a5, which will be a4 plus the common difference. So a4 is 3 upon 4 plus 1 by 4. Upon addition, it becomes 4 by 4, nothing but 1. Sixth term is a5 plus common difference. a5 is 1 and the common difference is 1 upon 4. 1 by 4 will be 5 by 4. Seventh term will be sixth term plus the common difference. Sixth term is 5 upon 4 plus 1 upon 4 is added. We get 6 upon 4, nothing but 3 upon 2. This is how the next three terms are found. These are next three terms. Let us take up the second sub question. 5, 14 by 3, 13 by 3, 4 and so on. Again we need to find the differences by taking the each consecutive terms of this series. So let me find out the first difference. D1 I'll write, which is a2 minus a1, which is 14 by 3 minus 5. On taking LCM, we get 14 minus 15 by 3, negative 1 by 3. The second difference is a3 minus a2. So 13 upon 3 minus 14 upon 3. The LCM is 3. We will be getting 13 minus 14, nothing but negative 1 upon 3. The third common difference is a4 minus a3. 4 minus 13 upon 3. We get 12 minus 13 divided by 3, negative 1 by 3. Here we have all the differences, first difference, second difference, third difference equal to minus 1 by 3. So it forms an arithmetic progression, forms an AP. Now we need to find the fifth term. Fifth term is fourth term plus the common difference. Fourth term is 4 plus the common difference is negative 1 upon 3. We'll be getting 11 by 3. Sixth term is the fifth term plus the common difference. Fifth term just now we have found as 11 by 3 plus minus 1 by 3 to be added. We'll be getting 10 by 3. Seventh term is sixth term plus the common difference. Sixth term is found to be 10 by 3 added to minus 1 by 3. We get it as 9 by 3, same as 3. These are next three terms of arithmetic progression. Look at question 3. The first difference here is second term minus the first term, which will be 2 root 3 minus root 3. It should be added or subtracted like variables, algebra. So second difference is a3 minus a2, which will be 3 root 3 minus 2 root 3, nothing but root 3. Here d1 and d2, they are equal to root 3, therefore it forms an arithmetic progression. Now we shall find the next three terms. Here there are three terms, we need to find the fourth term. Fourth term is the third term plus the common difference, and the third term is 3 root 3 plus the common difference is 4 root 3. A5 will be A4 plus the common difference. A4 is 4 root 3 plus the common difference, we get it as 5 root 3. A6 will be the fifth term plus the common difference. Fifth term is 5 root 3 plus root 3, 6 root 3. These are next three terms of arithmetic progression. Now the fourth sub question. Let me find out the first difference here, which is second term minus the first term. We will be getting a plus 1 plus b minus of a plus b. We get a plus 1 plus b minus a minus b. Here both a and b will get cancelled. We will be left out with only 1. The second difference is a3 minus a2, the third term. A plus 1 plus b plus 1 is the third term, minus the second term is a plus 1 plus b. Let me simplify this. Here when bracket is removed, we will get negative a, negative 1 and negative b. Here 1 get cancelled, a get cancelled, b also get cancelled. Again we get 1. We are having the first difference same as the second difference equal to 1, which implies it forms the given sequence, the given series forms an arithmetic progression. Now we need to find the next terms. Here there are three terms. We need to find the fourth term. It is the third term plus 1. So the third term is a plus 1 plus b plus 1 plus 1. We get a plus 2 plus b plus 1, or I can write it as a plus 1 plus b plus 2. There is no issue in that. A5 will be a4 plus 1, which will be a plus 2 plus b plus 1 plus 1. I can write it as a plus 2 plus b plus 2. So 1 is been added. Sixth term is fifth term plus 1. So a plus 2 plus b plus 2 plus 1. Now I'll consider along with a. So a plus 3 plus b plus 2. These are the next three terms. Let us have this fifth question as the last question for today's session. We'll find out the first common difference, which is a2 minus a1. Here we have 2a plus 1 minus a. We'll be getting a plus 1. The second difference is a3 minus a2. a3 is 3a plus 2 minus a2 is 2a minus 1. Because minus is been multiplied inside, we get it as a plus n again. The third difference is a4 minus a3. a4 is 4a plus 3 minus a3 is minus 3a minus 2. Again we get it as a plus 1. Here we have d1 equal to d2 equal to d3 equal to a plus 1. The common difference exists. Therefore, the given series forms an arithmetic progression. With this, I can find the fifth term, which is a4 plus the common difference. a4 is 4a plus 3 plus a plus 1. This is the common difference. When added, we get 5a plus 4. Sixth term is a5 plus d. We get 5a plus 4 plus a plus 1, which will be 6a plus 5. a7 will be a6 plus d. We get it as 6a plus 5 plus a plus 1, which is 7a plus 6. These are the next 3 terms of arithmetic progression. With this, we'll end the session. We shall start with the next question onwards in the next session. Thank you.